Hello and welcome back to the course on deep learning. Today we're talking about stochastic gradient descent. Previously, we learned about gradient descent and we found out that it is a very efficient method to solve our optimization problem where we're trying to minimize the cost function. It basically takes us from 10 to the power of 57 years to solving a problem within minutes or hours or within a day or so. And it really helps speed things up because we can see which way is downhill and we can just go in that direction and take steps and get to the minimum faster. But the thing with gradient descent is that this method requires for the cost function to be convex. And as you can see here, we've specifically chosen a convex cost function. Basically, convex means that the function looks similar to what we are seeing now, that it's just convexed into one direction and that it, in essence, has one global minimum, and that's the one that we're going to find. But what if our function is not convex? What if our cost function is not convex? What if it looks something like this? Well, first of all, how could that happen? Well, that could happen because if we, first of all, choose a cost function which is not the square difference between y hat and y, or if we do choose the cost function which is like that, but then in a multidimensional space it can actually turn into something that is not convex. And so what would happen in this case if we just try to apply our normal gradient descent method? Something like this could happen. We could find a local minimum of the cost function rather than the global one. So this one was the best one and we found the wrong one, and therefore we don't have the correct weights. We don't have an optimized neural network. We have a subpar neural network. And so what do we do in this case? Well, the answer here is stochastic gradient descent. And it turns out the stochastic gradient descent doesn't require for the cost function to be convex. So let's have a look at the two differences between the normal gradient descent that we talked about and the stochastic gradient descent. So normal gradient descent is when we take all of our rows, we plug them into our neural network. And once again, here we've got the neural network copied over several times, but the rows are being plugged into that same neural network every time. So there's only one neural network. This is just for visualization purposes. And then once we've plugged them in, we've calculated our cost function based on the formula on the right and looking at the chart at the bottom. And then we adjust the weights then. And this is called the gradient descent method, or it's also the proper term is the batch gradient descent method. So we take the whole batch of from our sample, we apply it, and then we run that. The stochastic gradient descent method is a bit different. Here we take the rows one by one. So we take this row, we run our neural network, and then we adjust the weights. Then we move on to the second row. We take the second row, we run our neural network, we look at the cost function, and then we adjust the weights again. And then we take another row, take row 3, we run our neural network, we look at the cost function, we adjust the weights. So basically, we're looking at we're adjusting the weights after every single row rather than doing everything together and then adjusting weights. Two different approaches, and now we're going to just compare the two side by side. So here they are. This is how to visually remember them. So you've got the batch gradient descent where you're adjusting the weights after you've run them, after you've run all of the rows in your neural network. And then basically you adjust the weights and you run the whole thing again, iteration, iteration, iteration. In the stochastic gradient descent method, you run one row at a time and you adjust the weights, you adjust the weights, you adjust the weights, and then you do everything again and again. And that is called the stochastic gradient descent method. The main two differences are that the stochastic gradient descent method helps you avoid the problem where you find those local extremums or local minimums rather than the overall global minimum. And the reason for that in simple terms is that the SGD, or the stochastic gradient descent method, has much higher fluctuations because it can afford them. It's doing one iteration or one row at a time, and therefore the fluctuations are much higher, and it is much more likely to find the global minimum rather than just the local minimum. And the other thing about the stochastic gradient descent method compared to the batch gradient is it's faster. Like the first impression that you might have is because it's doing every single row one at a time, it's slower, but actually, in fact, it is faster because it doesn't have to load up all the data into memory and run and wait until all of those rows are run all together. It can just run them one by one, so it's a much lighter algorithm. It's much faster in that sense. So though it has way more, in those senses, it has more advantages over the batch gradient descent method. The main advantage of, or the main kind of like pro for the batch gradient descent method is that it is a deterministic algorithm rather than stochastic gradient descent being a stochastic algorithm, meaning it's random. And with the batch gradient descent method, as long as you have the same starting weights for your neural network, every time you run the batch gradient descent method, you will get the same iterations, the same results for your for the way your weights are being updated. For the stochastic gradient descent method, you won't get that because it is a stochastic method. You're picking your rows possibly at random, and you are updating your neural network in a stochastic manner, and therefore you're just going to, every single time you run the stochastic gradient descent method, even if you have the same weights at the start, you're going to have a different process, different iterations to get there. So that's in a nutshell what stochastic gradient descent is. Also, there's a method in between the two called the mini batch gradient descent method, where you combine the two and you basically run, rather than running a whole batch or running one at a time, you run batches of rows, maybe 5, 10, 100, however many rows you decide to set. You run that number of rows at a time, then you update your weights, and so on. And that's called the mini batch gradient descent method. If you'd like to learn more about gradient descent, there's a great article which you can have a look at. It's called A Neural Network in 13 Lies of Python, Part 2, Gradient Descent by Andrew Trask. And the link is below. It's on GitHub, 2015 article. Very well written, in very simple terms. It's got some interesting philosophical or just interesting thoughts on how to apply gradient descent, what are the advantages and disadvantages, and how to do things in certain situations. So it's got some very cool tips, tricks, and hacks. Very easy read, so definitely check that out. And another one, a bit more heavier read for those of you who are into mathematics, who want to get to the bottom of the mathematics, why gradient descent in that specific, what are the formulas that are driving gradient descent, how is it calculated, and so on. Check out the article, or actually the book. It's a free online book called Neural Networks and Deep Learning by Michael Nielsen, 2015 book. It's just basically, it's all online. You can go ahead and check it out there. And they're, again, very soft introduction to the mathematics, but the mathematics are pretty heavy as you go along, as you read through the article. But at the same time, it gets you into that mood. I think even it has like a warm-up chapter where you first warm up with the math and then you jump into them. So interested in math, then this is the article to go to. And there we go. So that's in a nutshell the difference between gradient descent and stochastic gradient descent, and how the two work. And on that note, we're going to wrap up today's tutorial. I look forward to seeing you on the next one, and until then, enjoy deep learning.